Hi guys, I'm happy to see so many people actually interested in this topic. In the next 20 minutes, I will give you tips on how to organize complex game content to streamline workflow. And I write here that these are best practices for game designers and engineers, but in reality, this topic can be interesting for any role that focuses on improving the productivity of game design teams. But before we start this topic, before we dive into the topic, I would like to get to know each other. And we will start with you. Do we have here people that are neither game designers nor engineers? Yeah, don't be shy, raise your hand, okay. Good, so we have quite a few. But no worries, because I will be very detailed in my explanations and provide a lot of examples, so you will understand most of the content, even if you don't have any engineering or game design background. And now, a few words about myself. For the last 6 years, I've been in the gaming industry helping game developers to find tools to create successful games. Previously, I've been working at Dev-to-Dev analytics platform, and right now, I'm the head of growth at Balancy. I'm captivated by the topic of live ops because this is really the best strategy to create more fun and engaging games. And I write on this topic on LinkedIn quite often, so if you're there, please feel free to add me on LinkedIn, and this way we will be in touch. All right, now let's dive into the topic. I like talking about game designers as the magicians of the gaming industry, because they have this power in their hands to create the games that we all love so much. And their magic wand are simple spreadsheets. In spreadsheets, they store some in-game items. They calculate pricing. They calculate level and experience progression, and do so many other things. This is an example of such a table in the hands of game designers. This particular table lists some spells that exist in the game, but you can actually work with so many different types of content in spreadsheets. And spreadsheets are a great and reliable tool in most cases. They are perfect for storing some simple in-game items, for managing pricing, calculating progression. But when it comes to more complex data, it can be quite tricky and challenging. For example, when we talk about quests or spells, there are certain difficulties to work with it in spreadsheets. So right now, I suggest you to focus on what I mean by this complex data. First of all, quests and tasks, which are an essential part of so many games. Just imagine how boring World of Warcraft would be without quests, or Lily's Garden without to-do board. There are different types of quests. There are campaign quests, which are tightly connected to the plot of the game. There are side quests, which are optional. There are daily quests, which need to be completed every day. Event quests related to certain celebrations, and so on. And there are a lot of tasks that quests can include. And these tasks vary from slaying your enemies to collecting some items to basically trimming tree in your garden. And because of this complex nature of quests, because they include so many different tasks, it can be quite challenging to work with it in tables and visualize this data. Now, the next type of data that I call complex data is items from survival games, simply because any survival game is built around tons of items. There are items that can be, for example, consumed, like a bottle of water or a piece of meat to restore hit points. Some items can be used as equipment, like clothes. Some items can deal damage and used as a weapon, for example, swords or guns. And remember that when your game grows, the list of items grows exponentially, and you come up with a table that basically has like hundreds of columns. And this is not a very convenient way to work with items. The next type of data are spells and abilities. Just try to remember how many spells you might know from such games as League of Legends or, again, World of Warcraft. For example, you can use Ignite to burn your enemy for a couple of seconds, or you can use Heal to restore the health of your own champion, or you can use Barrier as a shield from the damage. Each spell may have many different effects, and it's quite tricky to work with this number of different effects in tables. As a game designer, we need to find a solution to work, to store, and manage this game balance. And we will do it right now with you here today. When we are looking for a solution, we should keep in mind, first of all, game designers, who are going to be the end users of the system that we are creating. It should be easy for them to navigate around. But we also cannot forget about engineers, because in the end, they will be the ones who are taking this code from the tables and uploading it into the game. Here I listed 3 approaches that I have seen game developers use, and I will start from less convenient ones and come to the most optimal one, which is composition. At first glance, all these 3 options can be workable, but you will notice the difference when the content in your game starts growing. In the end, composition will become the most optimal solution. So the first solution is actually one of the most popular ones, and I call it huge tables. It's not an official name, but these are literally huge tables. So what do we do here? Here's an example of spell system in a game, and in the column B, you simply list all the spells that your game has. In the names of the columns, you list effects that they have. If a spell has a certain effect, you put a value. If a spell doesn't carry a certain effect, you put 0. This way, you assume that each spell carries every effect, just some of them have value 0. And let's try to read such a table. So for example, we have first item. I think it's Fireball, which flies at a distance 50 with speed 10 and deals 100 damage. But when it comes to slowdown and duration and radius, we have 0 values. Then we have Frost Nova, the third item. It deals 100 damage, but it doesn't have any distance or speed because it's a different type of spell. It's the spell that surrounds the champion, so it doesn't fly. It's not a flying ball. So the inconvenience of such approach is that at some time, you will have so many items and so many effects that it will be difficult to read for game designers. And also for programmers, it will be not an optimal way to work with such huge classes, because in this example, the class will be like a huge class listing all the parameters with zeros. So in the end, it's not a recommended practice for programmers. That is why when programmers see a huge table, they often approach it with inheritance to make the code kind of more compact and easier to work with and scale. Inheritance is a programming term, which means that to create a new class of objects, you need to borrow code from the previous class and just you add some new features to it. And inheritance works great in many cases, but it doesn't work for spells and quests. Here's visualization of inheritance with spells. First, we have some class with abstract spell. Then we create flying ball spell with inheritance. For example, we have such instances as Fireball, Frostball, which are created from there. Later on, we decide to inherit mass area damage spell from abstract spell. For example, Fire Explosion or Frost Nova. And everything works great up to this moment. But later on, you may find yourself in a situation when you want to inherit from both classes and create, for example, a Fireball with mass area damage. On the one hand, you can inherit from Flying Ball spell. On the other hand, you can inherit it from mass area damage spell. But you cannot inherit from both at the same time, because that's just simply impossible. So this is a tricky situation, which is easily solved with our next solution, which is composition. Composition works great in any case that you can imagine. It works great for spells, for items, yeah, basically for any scenario that you can imagine. And it's all due to its Lego nature. It's very flexible. Basically, you define different components or bricks of your Lego, and you enable these components with some visual appearances or behaviors or some qualities, effects. For example, in this case, we're talking about spells, so we can make our objects fly, deal damage, burn damage, slow down, and so on. And then when we need to create a new spell, we simply combine several effects. For example, if we want to create a firebolt, we will take flying, deal damage, and burn damage component. If we want to create fire nova, we combine area spell with deal damage and pushback effect. And for programmers, it's super convenient to work this way because all of these effects are isolated classes. They're very small, so it will be very convenient for them to work with these small classes rather than this huge class that we saw in huge tables. So to add a new effect to the game, also they just need to add support only for this new effect. They don't need to change the code of the rest of the game. And what about game designers? For game designers, composition may look like this. You can already see that it's a very convenient way to read things. So instead of having many, like hundreds of columns, we have one column which is called effect, and we put all components in just one column. So this column includes, each spell includes only components that it needs. We do not put zeros, like in huge tables. So we can read just a couple of examples to see what is actually depicted here. The first spell is a fireball. It has linear move 10 with max, it flies at distance 50. It has single target effect, which means that it can hit only, it's activated only once it hits the target. And it deals damage 100. The next spell is a frostball. And it has very similar effects, just with the difference that it also slows down our enemy by 30% during 3 seconds. So the logical question you may ask, is it possible to recreate this kind of logic, composition logic in tables? Yes, you can try. You can try to put all effects in one cell in a spreadsheet and use some probably operators like comma to divide them. But in the end, it will not be very readable. And it will be also prone to human mistakes because it's very easy to forget just one operator. And then, for example, your programmer doesn't notice it. He uploads the game balance, and the logic of the game is broken. And alarm, alarm, you need to fix things quickly. So if you're working with composition, it's recommended to develop some kind of interface so that you avoid human errors and streamline your workflow. Let's look at more examples of composition. So this is actually a table from a real survival game called Grand Survival. And this game has a lot of items. And it also has around 100 actions, which can be in this column. And each of the actions may have up to 5 parameters. So if we were trying to recreate the logic of this survival game in huge tables, it would actually be a table with maybe 200 or 300 columns. That's definitely not something very readable. And here it's quite easy. You just select an item. For example, the second one is a knife. And we can see which actions it can do. We can see that it has durability, which means that eventually it will break after some usage. It's a wearable object, and we specify where it is attached to. It's attached to right hand of the character. We also know that it's a weapon, and it has attack radius, cooldown, damage delay. It costs us some energy to use this knife. And in item rank, we specify how it can be repaired and the maximum number of times that we can repair it. So we have seen that composition works great for survival game items, for spells. It also works great for quests and even tutorials. This is an example of a tutorial on how you can structure it in a table with composition. You can literally read the whole tutorial right in your table. We will not do it now, but I just wanted to show you the different applications of composition and why it actually more preferred way to approach things than huge tables or inheritance. And I would like to take the last minute of this presentation to thank people without who this lecture would not be possible. These are Pavel, the founder of Balancy, an amazing engineer and creator of MOBA game Uniworld. Also Serge Maskinsky, lead game designer at Big Cube Co. Actually, this was the survival game that I showed you. He is working on it. And Sergey from CD Projekt Red. Thank you for your time. And if you have questions, you can ask them now, or also you can reach out to me. Do you have any
questions for Julia? Any questions? Okay, how about a question from me? What about content management in quests that are not linear, that they branch in various ways? How to deal with that?
So, okay, when next steps of this quest depend on the previous steps, how they complete the steps. Okay. And actually, the question that goes a little bit beyond the scope of this lecture, but you can store this data still in tables, that's fine. But later you can also use visual scripting to show the branches of how the scenario would evolve if one step is like this, then you will have different branches stemming in your visual script. So that would be my recommendation. Thank you.
Thank you. Any other questions? Okay.
Hello, thanks for presentation. Just one small question. You shared the screens from some tool. So is it some in-house tool, or would you recommend some to use for a composition building?
I mean, with the screenshots that I showed are our own screenshots from Balancy and from our clients that we are making. But you can use it as an inspiration to develop in-house tool.
Thank you.
Do we have any more questions?
Hi. You showed this list of skills, of spells, for example. Do you know how to work with some kind of tools that somebody who's not related with the programming could be, via some kind of interface, create new stuff? Like, we are the developers, we give to somebody who can create by his own extra spells with custom fields, and the game should work with this stuff what the people create, so some totally random stuff. Is it how do you
without the programmer involved?
Yes, so like you create interface for like you could create your own levels, your own spells. Like we give, or maybe some game designers in company, and like something like middleware, so somebody could via this kind of interface create new spells, and it should work on games.
So just to clarify, you're looking for a tool, or you're looking for some consultation, like for a person who would do it?
More curious question. How is it prepare the code for this kind of open data? Like players could create their own spells. We have, for example, a game.
Okay, if players create their own spells. Oh, that's an interesting question. We can think about it. Like if you're talking about your own game, yes? Like, okay, cool. I would be happy to have a chat with you about it, because I think I know a way to approach it, but I will be curious to learn more about how these spells are created, what are how people can be creative with them. Is it how many parameters and effects these spells may have, and maybe we can help. Okay.
Thank you very much, Julia. Give a round of applause.